In this video here, we're going to be looking at the Chapter 4A's review for the test. And so let's start with complementary and supplementary angles. When we're talking about complementary angles, that's when two angles add up to give you 90 degrees, or in radians term, that is pi over 2. Two angles that add up to give you pi over 2. For supplementary, that's when they add up to give you 180 degrees, or in radians term, that is pi. Two angles that add up to give you pi. Now here we're given one in degree and one in radians, so let's go ahead and find the one in degrees. So if I want to find something complementary to 42 degrees, I would take, so I'm just going to put C for complementary. I would just go ahead and take 90 degrees and subtract 42 from it. And if I were to subtract, I get 48 degrees. So that would be my complementary angle. For my supplementary angle, I would take 180, subtract 42. And so the difference there would be 138 degrees. And so I have my complementary angle and I have my supplementary angle. For this one, it's in radians, so we are going to need to make sure we use the radians form for 90 degrees. So if I want to find the complementary angle, I would take pi over 2 instead of 90 degrees and subtract it from 2 pi over 5, the degree that I have. Now I need common denominators if I want to subtract fractions. So I'm going to make both denominators a 10 by multiplying the top and bottom for the first one with a 5. So I can make it a 10. So that'd be 5 pi over 10 minus, let's see, this one I can multiply by 2 on the top and bottom. So that would give me 4 pi over 10. So if I were to subtract 5 pi with 4 pi, I get 1 pi over 10. And that is it. So my complementary angle is pi over 10. To figure out what the supplementary angle is, I have to take pi and subtract it from 2 pi over 5. The nice part here is that with this being a whole number, I can always, put pi over 1 and make the denominator whatever I want to match up with this denominator. So if this is a 5, I can multiply the top and bottom by 5. And so this would end up being 5 pi over 5 minus 2 pi over 5. So if I subtract the top, that would give me 3 pi over 5. And so I have my complementary angle and my supplementary angle. And there we go. Okay, so let's move into coterminal angles. So in this case here, when you're finding coterminal angles, you do need to make sure one of them is positive and one of them is negative. It does not matter how you get there, but you need to make sure one is positive, one's negative. So just as a reminder, if you want something that's coterminal, you have to add 360, or you can subtract 360. But if you have something in radians, you have to either add 2 pi or subtract 2 pi. So we always use 360 or 2 pi because we want to go one full circle around the unit circle, or one revolution is what we call it. So like this one here, if I want a positive coterminal angle, maybe the best thing to do is to add 360. If I were to do that, that would give me 675 degrees, and that is a positive number, so I can use that as my positive coterminal angle. Now for my negative, I'm going to take 315 and subtract 360. And so that would give me negative 45 degrees. So because this one's negative, this one's positive, I can stop right there and just use these two as my positive and my negative coterminal angles. Now for the next one, this one's a little bit different because it is in radians. So I have negative 5 pi over 6. First off, I'm going to try to get a positive coterminal angle by adding 2 pi. Now this one's not a fraction, so I'm going to put it over 1 to make it a fraction. So I can make the denominator both a 6 if I multiply this side by a 6. So this gives me negative 5 pi over 6 plus 12 pi over 6. So negative 5 plus 12 gives me 7 pi over 6. And this is a positive number, so I'm going to stick with this being my positive coterminal angle. Now, to get a negative coterminal angle, I need to take this and subtract by 2 pi. So doing the same thing here. The nice part is that I already know what a common denominator is. If I want a 6 in the denominator, it's just 12 pi over 6. So I'm just going to kind of skip ahead. So I have negative 5 pi over 6 minus 12 pi over 6. So if I subtract 5 pi with 12 pi, I get negative 17 pi over 6. So I have my positive coterminal angle and my negative coterminal angle. And that's it. So getting into converting angles, so you need to be able to convert a radians to a degree and a degree into a radians. So let's first remind ourselves, how do we convert? So if you have something in radians here, you need to multiply by 180 over pi. So if you might remember this, anytime you have something that is radians, make sure the denominator has the pi and the top is the 180 for degrees. You want the pi in the denominator so you can cancel out the pi's diagonally when you're converting from radians to degrees. So when I multiply this out, I get the pi's to cancel. Looks like I have a 15 here and a 180. Let's see if I know it's divisible by 5, but let me check if 180 is divisible by 15. And it is. So it looks like 15 can divide into 15 one time, and 15 divides into 180 12 times. So if I multiply straight across, 4 times 12 gives me 48. And then the bottom is just a 1 left since the pi canceled. So 48 over 1 is just 48. So we have 48 degrees as our angle. So 4 pi over 15 is also 48 degrees. Moving on to this one here. This one is in degrees. So if you want to cancel out that degree sign, the 180 needs to be on bottom this time because 180 is in degrees, and pi needs to be on top. So when you're multiplying this out, it might be helpful if you put the 42 over 1. Some people just like to be able to multiply straight across. So looking at this here, 42 and 180 are both even numbers, so I can kind of try to reduce this. I'm going to try out a few things. Let's see if 180 is divisible by 42. I don't think it is. Yeah, so I'm just going to divide by 2 first. So 2 goes into 42 21 times, and 2 goes into 180 90 times. So if I multiply straight across, this is going to be 21 over pi, and then 1 times 90 is just 90. Now, they are both divisible by 3. 21 is divisible by 3. If you divide it, you get 7. And then if you divide 3 into 90, you get 30. So this gives me 7 pi over 30 for my radian. So I've just converted 42 degrees to radian 7 pi over 30. All right, let's move into the next topic, which is given an angle, you have to figure out what quadrant you're in. And you can use the unit circle to help you out. That might really help you figure out what degree and coordinate you would be in. So this one here, you are in 233 degrees. If you were to draw, coordinate system, you have 0, 90, 180, 270, 360. So in this case, this angle would be somewhere in the third quadrant because 233 is somewhere between 180 and 270. So this is the third quadrant. All right, let's check out the next one here. So this one is negative 130. So if I were to draw this here in the negative direction, this would be negative 90, negative 180. So negative 30 would have to be somewhere also in the third quadrant, because negative 30 is a number between 90 and 180. So this one is also the third quadrant. This next one here is in radians. Both of these are in radians. This one's tricky because pi over 5 is not on the unit circle, but if we just critically think about it, you have generally 0, pi over 2, and then pi, 3 pi over 2, and then 2 pi. So I know that like in this quadrant here, that's where you have pi over 4, pi over 3, pi over 6, right? So in this case, when I'm looking at pi over 5, I think it's going to have to be in the first quadrant. And if we want to try to prove this here, we can always try to find a common denominator. Like this pi over 2, if we want a common denominator with 5, we can make both the denominators a 10. So if I wrote pi over 2 with a denominator of 10, this would be 10, 5 pi. And this here, if I want a denominator of 10, this would be 10, 2 pi. Because 2 divided by 5 would reduce to 1 over 5. And 5 divided by 10 would end up being 1/2. So when I look at this number versus this number, pi, this is smaller. So that means that pi over 5 had to have been somewhere in the first quadrant. It wouldn't have surpassed pi over 2. All right, so that one is in the first quadrant. This one here is a negative pi over 4. If you guys know where pi, positive pi over 4 is here, so negative pi over 4 would be down here in the fourth quadrant, it looks like. Which makes sense because this one here would be negative pi over 2, and pi over 4 would not be bigger than pi over 2. So that one's in the fourth quadrant. All right, so number 11 here is a level 2 problem where you're trying to figure out what tangent is given a trig function. So early on, before you even learn about coordinate system, you know about the different ratios based on opposite, adjacent, and hypotenuse. So because I have sine, that means that I know that this 2 is my opposite, and this 5 is my hypotenuse, because sine is always opposite over hypotenuse. If that's the case, if I were to draw a triangle, and this is my theta, I have 2, which is going to be on my opposite side, and 5 is my hypotenuse. I don't know what the adjacent is, and I do need it because I need to know what tangent is. So just as a goal here, we want to know what tangent is going to be, which is the opposite over adjacent value. So in this case, if I were to try to figure out this side, let's see. We could use Pythagorean theorem, which is originally a squared plus b squared equals c squared. So I can plug in my hypotenuse, which is 5. I can plug in my 2. And then just solve for the missing variable, which is the adjacent side. So this would be a squared plus 4 equals 25. And then if I subtract this over, this would be a squared equals 21. Take the square root of both sides. This would end up being a square root of 21. So this is square root of 21 here. And then what I need to do is find my tangent value. So I have my opposite side, which is 2. My adjacent side is going to be root 21. So that means I need to multiply the top and bottom by root 21 to try to get rid of the root. So I have 2 root 21 over 21. So the 2 roots cancel, leaving me with just 21. I can't reduce a 2 and 21, so this is it. This would be my final answer. All right, let's try out cosecant here. So cosecant is the reciprocal to sine. So this 7 here needs to be my hypotenuse. And then the 3 here is my opposite. So cosecant is always hypotenuse over the opposite, since it's the reciprocal of sine. So if I were to draw this triangle here, and this is my theta, I know my opposite side is 3, my hypotenuse is 7. I need to also find my adjacent side. Now before I do, I need to figure out what cosine is. So cosine is the adjacent over the hypotenuse. So I do need the adjacent side. So using the Pythagorean theorem, a squared plus b squared equals c squared. I'm going to plug in my what I have. So make this one squared. I'll keep the a empty. I'll square the 7, my hypotenuse. So if I work this out, I get 9 equals 49. 7 squared gives me 49. So I can subtract the 9 over, which gives me 40. Take the square root of that. And my a here is square root of 40. But you do need to simplify the 40 and break down the root. So the root breaks down into 4 and 10. And so 4 breaks down into 2 and 2. 10 only breaks down to 5 and 2. So the 5 and 2 are not pairs, but the 2's are. So in this case, the 2 comes out. And then my root here, 5 and 2 are not pairs, so they go back in the root. So you have to multiply them, so 10 goes back in the root. So you only bring out duplicates or pairs, and you keep any leftovers back in the root. So a here is, or the adjacent side is 2 root 10. From here to find cosine, I need to plug this in for the adjacent, which is 2 root 10. And then my hypotenuse is 7. And I can't really do much after that. 2 and 7 don't reduce, so this is it. So I will end this video here. In the next video, I will explain how to do the next page of the review.